Okay, today I'm going to use the very quick way to explain the basic of the standard normal distribution. I think this is from 5 chapter for mx. Okay, so when we talk about standard normal distribution, some basic information you have to know. First is what? First is you will see some graph look like this. Okay, this is the standard shape for standard normal distribution. Okay, and then you will see a straight line like y-axis like that. He cut here and then he cut at 0 here. Okay, first you have to know actually the line here. The line here is about the z value. So this straight line you have the z value, which is you will see something like probability z is bigger than 2.033. That means what? That means the 2.033 will in this straight line. Okay, if this is 0, means this is positive z value here, and this is the negative z value here. Negative z value will be here. So let's say if this is 2.033, and maybe here you will have the negative 2.033. Okay, because this here will be positive, here will be negative. And then this straight line, he cut this bell-shaped graph into the half. That means this side is symmetric with this side. Okay, when you listen to the word symmetric, what is the meaning by symmetric? Symmetric will mean that the size of here will same with the size of here. And then if you know about probability, the total probability will be 1. Okay, probability will be always between 0 and 1. Okay, probability is always between 0 and 1. When you got probability 0 means what? Means the things will never happen. If you got the probability is 1 means what? 1 will mean the thing is must happen. Therefore, probability is here. This area is for probability. So because this is symmetric, total probability will be 1. So the half here will be 0.5. So another half here you will have 1. So another 0.5 will be here. Okay, because they are symmetric, so both of them plus together must be 1. So this is the probability. Probability will be here, and then the bottom straight line, this one is the z value. Okay, and then in the exam you will see some table like this. This is what we call standard normal distribution table. So actually you can find all the value from this table. Of course you have to know how to use this table, and I believe in your SPM MX exam actually you are given this table in front of the paper. Okay, so let's start the first question. Okay, first question he asked, when this is P stand for probability, z bigger than 2.033. Okay, when you see bigger will means what? Bigger will mean go this direction. So imagine if this is the bell diagram, if I cut half, okay, bigger mean go this direction. So I assume, let's say I assume this line is 2.033. Therefore, bigger, if this line here is 2.033, because this is z value, bigger means go this way, called bigger. Smaller means go this way. Okay, bigger go this way. So I will have this area. That means this area, I say all the area here is the probability value. So you have to find what is your probability value here. Okay, you have to find what is your probability value here. Therefore, you find this one from the table. Okay, 2.033. So actually you from this table you have to find, because 2.03 you have to find 2.0. 2.0 will be somewhere here. Okay, do you see 2.0 here? Okay, 2.033. So 3, 3, first you have to have a look at the first 3 here, and then go down to 2.0. You got 0.0212, another 3 here. These 3 you will see subtract. What's the meaning by subtract? Subtract will mean you have to minus the 3 value here. We move until here, you will see 1. Therefore, 0.0212 have to minus the 1 at the last place here. So therefore, you got 0.0211. Okay? Therefore, the probability for this one, I will got what? The probability value for this one, we will got 0.0211. Okay, this is the value you will got from this table. Okay, if okay, then okay, and then got some extra information is that in this chapter, this symbol and this symbol got no difference one. Okay, let's say you got z is bigger than some value a, or y is bigger than some value b. In this chapter, bigger and equal is no different one in this chapter. So you will never see I draw a dashed line here because this one got no equal. I will still draw a full line. So in this chapter, only bigger and smaller got the difference. Okay, so this is something you have to remember. Okay, and then okay, so therefore we got this value. What is the meaning by this value? This value means the probability here, 0.0211. Okay, mean this is the very small possible for something to happen, because you got not even 0.5, you got 0.0211. Mean actually is like if let's say this is 0.02, mean actually you try 100 times, this one can only happen 2 times. So this is very small probability here. So remember, the value here is for probability. Okay, then we go to next one maybe. Okay, you got something like this. He asks you to find probability z is between 1.5 to 2.033. Okay, for 2.033, just now we just got the value is what? 2.033, we got the probability value. Probability value for 2.033 is what? It's 0.0211. Okay, now he asks us to find the z. Okay, find the z value between 1.5. Find the probability of the z value between 1.5 and 2.022. So let's say I draw the Bell diagram and then I draw a straight line. Okay, because 1.5 is still positive, all the positive value is here. So this is 0. So all the positive value is here. So I assume okay, this straight line is 1.5, let's say. And then I assume this straight line is 2.033. So the area you want to find is on between. If this is 1.5, this is 2.033, you want to find the area is on between. Therefore, if you want to find this area, you have to use, okay, this one you must remember, in this table, all the value you find here is like z is bigger than something. Okay, for example, okay, when you can straight away find a table when he asks you probability, let's say z is bigger than 1.5. Then when you see the bigger value, you can straight away find 1.5 here. If you got p, z is let's say smaller than 1.5, then you have to draw out the graph first. You don't straight away find from the table if you got smaller, simple. But then if you got bigger, you can actually straight away find this table. So in here, in order to get this area, what I need to do is I have to use the biggest one. Let's say this is 1.5. Means I use the whole area. Okay, I use this whole area minus the small value, the small area here. I minus the small area here. What is the meaning? The meaning is Okay, I use, if let's say probability for z is bigger than 1.5. Okay, z is bigger than 1.5. When I say this is line 1.5, bigger than 1.5 is this is here. So I use the whole area here, minus the small area here. So I minus probability for z is bigger than 2.033. Okay. You have to understand this one very carefully. When I see z is bigger than 1.5, it's the whole area. Not only this area, it's the whole area like this. So this one actually is the whole area like this. Let's say this is the whole area like this. And then I minus this one, 2.033. So let's say 2.033 is here. Mean I use the whole area minus the small area here. Mean actually I minus the small area here. This one is here, so I can get this one. It's exactly here. Therefore, this is the way when you ask to find the z value on between, you have to think how can you get this area. Okay, because sometimes you have to use 1 minus the whole thing, but then in this example you don't need, because you want is between 1.5 and 2.033. You just draw first z is bigger than 1.5, mean this area. And then I minus z is bigger than 2.033. I minus this area. The whole area minus this area, I can get this area. Okay? Then I can straight away find the value in the diagram here. So first 1.5. So I straight away find 1.5. 1.5 will be here. Okay, this one is 1.5. This is called 0.0668. Okay, so this is 0.0668 minus this one, we got the value just now, 0.0211. So you just press the calculator, you can got the value. I think the value will be 0. Okay, 0. This is 457. 457 means what? Means this is the probability value. Means the area of here, because this is for the probability, so it means the area for here will be 0.0457. Means for this area. Of course, the size of this area is not accurate because I just assume. Okay, because if you like the whole thing is 0.5, 0.04 will be something very tiny. But then this one is just, I just draw out to make you understand which area I want to find. Okay? If okay, then maybe we go to the next example. Okay. If he asks you to find negative value here, so I quickly draw a diagram. Okay. This is negative 1.5, this is negative 2.033. So I imagine the negative 2.033 is here. Negative is over here. So I assume this is negative 1.5. That means in this question, he wants me to find here, this area. So in order to find this area, I have to use the whole area minus the small area. Okay? And then this one, okay. When you see negative, means what? Means if I use the whole area like this, this is called what? Probability for z. Go this way, correct or not? Go this way is smaller than negative 1.5. M minus, go this way for this one. Probability z is, go this way will be, go this way. Okay? Negative 2.033. Okay? If you use this one to minus this one, you can get this area. But then one problem here is because in this table you cannot see any negative value here because all value here will be positive. Therefore, you have to change the negative to positive. So what can I do is, actually he have some sort like formula. When you see negative, you want change to positive, you just change the sign. So you negative want to change to positive, you just change the sign. So this one we call what? Probability for z will be bigger than 1.5. See, when I change the sign, the negative go no more already. Okay, because they believe in this diagram, the area for this one, negative 1.5, smaller than negative 1.5, is the same area with the positive 1.5 here. It's same area means they believe this area is same with this area. So actually, they allow you to use this one to substitute this one in order to find the area on between. So same thing, minus probability Z. Okay, smaller, you just change to bigger, and then the negative got no more, 2.033. That means this one we find the value just now. Probability Z is bigger than 1.5. We have got 0.0668, 0.0668, and then minus 0.0211, and then we have got the same answer, 0.0457. So from this example, actually we can easily understand that even this is negative area, this is positive value, this is positive area, but then their Z value have the same value, we can get the same probability. Mean actually the area in the positive or the area in the negative actually is the same, because they are very fair one. This is 0.5 probability, this is 0.5 here. So actually the Z value you got here is same with here. Even they got negative, you will still have the same value. See, you will have the same value here. Okay, if okay, then we go for this one. Okay, let's see this one. Okay, when you see this symbol, this is sometimes they call it absolute symbol. Okay, what is the meaning for this symbol first? Okay, when you see this symbol, if I draw the Bell diagram, you see this symbol, it means what? When you see this symbol bigger than 0.845. When you see this symbol is bigger than 0.845, the meaning of this will mean that if this is 0.845 and here also is negative 0.845, okay, the area the question want to find is here. When you see bigger, means outside. Okay, this is the area the question want to find. Okay, and then if you see the symbol smaller, okay, this is Bell diagram. If let's say same to above one, this is 0.845, this is negative 0.845. Okay, if you see negative, it means that the area they want to find is on between. Okay, this is the difference between when you see this symbol and then he got bigger, and when you see this symbol, then he got smaller. Smaller will mean on between. Bigger will mean actually he go two sides. Okay, so in order to get this one, it's very simple. First, we want to get this one. So I say when you want to find the table, you have to get the bigger value. Z bigger than 0.845. Because Z bigger than 0.845, this is line 0.845. Bigger is mean here. Okay, and then I say this area will same with this area. Therefore, the whole thing I multiple 2. Then I can get the whole area. Okay, so I just find the standard distribution, the standard normal distribution table. This is what 0.845. So I find 0.84. Where is the 4? This is the 4 and 5. Mean you have to minus some value here. Here is 14. Okay, so 0.845. 0.845 means actually x4 here you will got 0.02005 minus 14. So 2005 minus 14. So I do some calculation here. 2005 minus 14, I will got 0.1981. Because this is 0. So minus 14. So I think we will got 19. Wait, this is called one. Oh, here actually don't need to borrow 1991. Okay, so that means what? This one is called 0.1991 is for this area, 0.1991. Because here actually he got the double of this one, that's why we multiple 2. We multiple 2, we just press the calculator, we can get 0. Let's say this is 289 or 3. Okay. Therefore, this is the answer you will get. Okay. For this one. Okay, this one they are on the middle. So of course we know actually this area is 0.1991. That means this area is also 0.1991. So the whole thing is 1. Okay, here is 0.5, here is 0.5. So the whole thing is 1. So I just use 1 minus both of these, then I can got the area on between. Okay, so I use 1 minus the whole thing in calculation above already. So it will be 0.3982. So I just use 1 minus 0.3982. Then I can got the area on between. So area on between will be 0. Okay, this one will be 8106. Okay, so the area I got will be 0.6018. Okay, thanks for watching. I will post more video on this. Thank you.